So I will solve the problems, answer the questions, which is the first online quiz. The first one is the question, which of the following is an example of a rotational motion? So the first one, the motion of a reflector on a bicycle wheel. So remember, there's a bicycle wheel. We studied this also in chapter 2, section 3. So this is a bicycle wheel. So the reflector is located on the spokes of this bicycle wheel somewhere here. As bicycle wheel is rotating, this reflector is also moving on a circular path. If an object is moving on a circular path, we say it is circular motion, not rotational motion. The motion of a bulb on the Ferris wheel, it's the same again. Bulb is following a circular path. That's why it is also circular motion. Motion of a horse on a carousel. The horse is following a circular path, so it's also circular motion. But a spinning Ferris wheel, the wheel itself, because the axis of rotation is just on the wheel, so then this is the rotational motion. Other three are circular motion. Next question is 1 over 2 pi revolution is equal to how many radian? So just simply use that. 1 revolution is how many radian? You should write it. 1 revolution is 6 pi or 2 pi radian. Remember, 1 over 2 pi revolution in this case, I will write it like 1 revolution is 2 pi radian. So 1 revolution is 2 pi radian divided by 2 pi. 2 pi simplify, it is 1 radian. So then we say that 1 over 2 pi revolution is equal to 1 radian. Next question is, an object moves from point A to point B along a circular arc of length L is equal to R. So from A to B, an object is moving. It's a circular arc whose length is R, which is the radius. The radius of the circle is also R, so which means arc length and the radius are equal. This is arc length, this is the radius. The angle whose arc length is equal to its radius of that circle is 1 radian. It's the definition of 1 radian. So the answer is 1 radian. Next one, a car tires rotates at an initial angular speed of 26.2 radian per second. So this is omega initial. The driver accelerates with constant angular acceleration with alpha, and car's tire reaches an angular speed of 54.6 radian per second in 8 seconds. So this is the final angular speed. In how many seconds? 8 seconds. This is delta t. What is angular displacement, which is delta theta of the tire in this time interval? So initial is given, final is given, time is given, delta t is asked. We are going to use the one of the kinematic equation. Delta theta is equal to 1 over 2 omega initial plus omega final multiplied by delta t. This is the equation which we are going to use for calculating the angular displacement, because it is a constant angular acceleration. So this is an accelerated motion. So 1 over 2, initial angular speed is 26.2, final is 54.6, multiplied by delta t 8. So we are going to calculate this. So let's start from 26.2 plus 54.6, which is equal to 80.8 divided by 2, multiplied by 4, multiplied by 8, which is equal to 223.2 radians. So the answer is D. And a ball is attached to a string of 2 meters long and turns in a horizontal circle. So a ball is turning on a circle, horizontal circle, and it is attached to a string 2 meters long. That 2 meters is the radius of this circle, of course, because the ball is moving on a circular path. So the string is the radius, length of the string is the radius of this circle. How far does the ball travel after 3-point turns? 3-point turns means 3.5 revolutions. Turns means here revolutions. 1, 2, and 3.5. So questions calculate how far does the ball travel. It's asking delta S, arc length. Remember, delta theta is equal to delta S over R. This is the relation between the angular displacement and arc length, and reduce. Because the arc length is the question, which is how far, delta S, R multiplied by delta theta is your question. So the equation, R is 2 meter, delta theta is 3.5 revolutions, but every revolution is 2 pi radians. So we should convert revolution to radian. If you multiply them on 2 multiplied by 3.5, 7 multiplied by 2, 14. 14 pi meters is the answer of this question. And question number 6. Angular speed unit may not be given as. So radian per second, revolution per second, or radian per minute, all are angular displacement divided by time, angular displacement divided by time, angular displacement divided by time, which is definition of angular speed. But meter per second, distance divided by time, which is the unit of tangential speed. Tangential speed. So that's why answer will not means going to be C. Find the average angular acceleration, alpha average, of a CD that changes speed from 20 radian per second to 5. So it is initial angular speed. This is final angular speed in time interval delta t. So we are going to use the definition of average angular acceleration, which is average angular acceleration is omega final minus omega initial, which is delta v, divided by delta t. Final is 5, initial is 20, divided by delta t, which is 5. Let's calculate it. 5 minus 20, which is equal to negative 15, divided by 5, which is equal to negative 3. So negative 3 radian per second squared is the average angular acceleration of this CD. And question number 8. The angle through which a point, line, or a body rotated in a specific direction about a specific axis is called arc length, angular speed, angular displacement, or angular acceleration. Of course, answer is angular displacement. It's definition of angular displacement. And question number 9. A car tire rotates 5.5 times in 2.5 seconds. This is angular displacement, delta theta. In 2.5 seconds, this is delta t. What is the rate of rotation of the tire? Rate of rotation means angular speed. It is the definition of angular speed. So it's asking you what is average angular speed, which is equal to delta theta over delta t. So answers are given revolution per second, revolution per second, revolution per second. So don't convert this revolution to radian because answers are given in revolution. That's why I will say that it's 5.5 revolutions. So then times means revolutions. So I will divide 5.5 by time, which is 2.5. So 5.5 divided by 2.5, which is equal to 2.2. So 2.2 revolution per second is the average angular speed or rate of rotation of this car tire. And question number 10. How long does it take to stop at the rail? Stop. Final. We will stop it. Final is 0. Stop means final angular speed must be 0. Which is initial turns. Initial angular speed at the angular speed. 262.4. This is initial angular speed. 262.4 radian per second. If it slows down with an acceleration, acceleration must be negative. So negative 41 meter radian per second squared. So then calculate the time. How long does it take? So we will use the definition of, or you are going to use the kinematic equation. So then average angular acceleration is equal to omega final minus omega initial divided by delta t. Remember, delta t is the question that find the delta t. Omega final minus omega initial divided by alpha average. Final is 0 because it stops. Initial is 262.4. Average angular acceleration is negative 41. So then we will calculate it. So negative 262.4 divided by negative 41, which is equal to 0.54 second. Pardon, there must be a mistake once again. Negative 262.4 divided by negative 41. Yeah, 41. Close the bracket, which is equal to 6.4. Sorry, 6.4 second is the answer. Answer is A. So this is the answer key of the first online physics quiz. Okay.